So in this example, we are going to be using Euler's theorem, and we have these three graphs here. It says use Euler's theorem to determine if the graphs shown have an Euler path or Euler circuit. So a couple of things to point out. An Euler path is a path that passes through every edge of a graph exactly once, while an Euler circuit here, a circuit is a path, but it's a path that starts and ends at the same vertex. And we're going to use Euler's theorem to determine if any of these graphs contain an Euler path or an Euler circuit. So Euler's theorem essentially says, I'm just going to kind of shorthand it or encapsulate it here. It says if that all the vertices of a graph are even, I'm just going to write it down here, then there's going to be at least one Euler circuit. There's probably many more, but it will contain at least one. And then another part about Euler's theorem is if exactly two vertices are odd, then there will be at least one Euler path. There's probably more, but it'll have at least one. So the key to understanding the nature of these graphs or the characterization of these graphs is to keep an eye out on the vertices. They tell us a lot. So for A here, I'm going to look at vertex A here. It's got 1, 2, 3. It's degree 3. It's got 3 edges emanating from it. B here has 1, 2, 3, 4. C has 1, 2, 3. And D has 2. So there's exactly 2 vertices, so there's going to be an Euler path on here. Now, the path has to begin and end at the odd vertices. So it's got to begin at A, since this is the odd one, and it's got to end at C, or it's got to start at C and end at A. So it's probably something of this nature. Here, this way, down this way, and we're going to end at the other odd vertex. So that's one particular path. There's probably a lot of them, but there's one. So this has an Euler path. For this graph here, B, the vertex A here, that's degree 2. This is also degree 2. It has 2 edges emanating from it. This is degree 4. 1, 2, 3, 4. This is degree 2. This is degree 1, 2, 3, 4. And this is also degree 4. So this graph has all even vertices. If it has all even vertices, then it contains at least one Euler circuit. And we'll do one. Let's do this. We'll start at F. And you could start at any one of these. You can go here to B, down to A, up this way, over here. And we're going to end right back at F where we started. We started at F, ended right back at F. So this has an Euler circuit. A circuit is also a path, but it's a path that begins and ends at the same vertex. And then for graph C here, we have 1, 2, 3. This vertex here is a degree 3. This is degree 2. This is also degree 3. And this is, don't forget, a loop is counted twice. So this has 1, 2, 3, 4. So this is degree 4. So we have exactly 2 odd vertices. So this is going to have an Euler path. And that path has got to begin and end at the odd vertices. So if we start here, we can go up. And it doesn't necessarily have to take this path. It could take another one. That's why we say there's at least one. Around and then we end up at the other odd vertex. And there we go.